Hi students, this is a video about chapter 16, Information Market Failure and the Role of Government from Microeconomics Bindike. Right, the chapter has got 7 sections. We will try to break it up into not more than 3 videos. Okay, the first concept here is the difference between a partial equilibrium analysis and a general equilibrium analysis. The partial equilibrium analysis is your usual demand and supply, where you introduce a shock to the equilibrium and you look at how the market readjusts itself automatically to arrive at a new equilibrium, with the assumption that other factors remain the same. Other markets are not affecting that particular market where you are studying the equilibrium in. But in reality, markets do interact with each other, and it is not just the price adjustments are being influenced by the factor in the market, but they are also influenced by factor in other markets. So that's why it's very important to understand the concept of general equilibrium analysis, where you have simultaneous determination of prices and quantities in all relevant markets, taking feedback effects into account. So there's a feedback effect. Okay, each market gives feedback to the other market simultaneously, and with that information they all come to a new equilibrium whenever there's a shock to any market. Okay, any one market, all the other markets will be affected. So let's take the simple case of two interdependent markets. Just try to start with two interdependent market, and just to show you why a partial equilibrium and general equilibrium are very different. Okay, so let's start with supply demand for movies, and here you have supply and demand for videos. Okay, and movie and videos are substitutes. Okay, all right, so and let's say tax is imposed on movies. So the new supply with tax curve is S. Is it S star, right? And then the new price after tax is 6.35. So people will buy less of movies, correct? And when they buy less of movies, they substitute by buying more of DVDs. So we see that demand increase for DVDs and price of DVDs go up to $3.50. Okay. But when price of DVDs go up to $3.50, then people substitute back DVDs to buy movies. Okay, so now demand for movies go up to D prime M, and this gives us a price of, so now the new equilibrium is 6.75. Okay, so this is why we say the interaction, this is in partial demand. You take it as if from one market, and then it affects another market. You study the market, and then that what happens in that market affect the other market. But this continues actually until a general equilibrium is reached. Okay, so that general equilibrium, the feedback effect between the two markets, will stop at a new equilibrium, which is at 682 and 358. Yeah, the dash, this one. Where is it? Yeah, this one. Okay, this is the new equilibrium, 682, and the final equilibrium, the general equilibrium, is 358. right? So to find the general equilibrium prices and quantities, we must simultaneously find two prices that equate quantity demanded and quantity supplied in all related markets. Yeah, so it's not just one set of price and quantity that clears one market, but two sets of prices and quantities that clear both markets, that can clear supply and demand at in all related markets. So you need to find solutions for four equations. Yeah? Supply for movies, demand for movies, supply of DVDs, supply for and demand for DVDs. So general equilibrium is usually a structural a system of equations, yeah, to solve for four equations. So you can read this example, very interesting, about with partial and non-partial, partial and general equilibrium. Okay, 16.2, efficiency in exchange. In exchange economy is market where two or more consumers trade two goods among themselves. Pareto efficient allocation is when the allocation of good in which no one can be made better off unless someone else is made worse off. Okay, so that's the criteria for efficiency, that no one can be made better off unless someone else is worse off. So that means both of them are already at their best position, at their most efficient position. That if you want to make someone better off, it means that someone else must be sacrificing for that movement or for that change to happen. Okay, so let's take this example of James and Karen. James and Karen have this initial allocation: 7 food, 1 clothing, 3 food, and 5 clothing. Yeah, and then their preference, their own personal preference, is that they like 1 food to 2 clothing, and Karen is 1 food to 3 clothing. Okay, so if they choose to trade, the trade will happen somewhere that gives both of them incentive to trade. Okay, that means they are better off where they are. So let's say they trade, the terms of trade is 1F to 1C, and so James trade, okay, sell 1 food and get 1 clothing. So Karen gets 1 food, okay, but sells 1 clothing. So the final allocation is this one: 6F to C, 4F for C. Okay, we are going to use the Edgeworth box to show possible allocations of either 2 goods between 2 people, or you can, in this case, yeah, for James and Karen, and later on we can use it to also show 2 inputs between 2 production processes, okay, to check whether they are efficient or not. So let's show the position. Now the Edgeworth box is like this, yeah. James clothing on this side, James food on this side, and then you sort of flip the graph so that you can have Karen's side. Karen starts, the origin is here, so Karen's food and then Karen's clothing. Okay. So from the perspective here, this is 0, 0. Remember just now 7F and 1C, right? So 7F and 1C, this is James' point. And then Karen, you start from here, you take 3F and 5C. So this is also Karen's starting point. So A is the original A is the initial point that shows the 2 persons consumption and efficiency later on. with two products. So you have two persons and two products. Okay. And when the trade happened, that means one. So James sacrificed one and got one. So James arrived at B, and then you can check Karen from her A, she sacrificed one clothing and achieved one clothing, and then one. She sold one clothing and got one food. So both of them arrive at B. Okay, so we're moving from A to B. Now, that is their exchange. Now we want to check whether that is efficient or not. So we use the Edgeworth box to include in this the indifference curve. Okay, so you can see A is here. Was that A is here? It is the point where you can touch, you are on one of Karen's indifference curve and also one of James' indifference curve. But A is clearly not efficient because it is not at the tangent point of, the efficiency of indifference curve is when you get the tangent point. That means you are on a certain utility, on a certain utility level, but you, at the same time you have tangent to anything. So if you cross something, if you intersect, that is not efficient. Okay, so it must be a tangent of some of the indifference curve that you are on. That means you want to reach the most minimum or the most maximum point possible for Karen on this will be on this side, and then the most maximum point possible for James will be as far as we can on towards the right hand side, above for James. So the green one should be the furthest up, and then for Karen the point should be furthest pink. So A is clearly not efficient. That's where they started with. What about after trade in B? Is that efficient? They moved up to higher, right? They did move up to a higher indifference curve, but still it is not efficient because it is an intersection, point of intersection. So let's see on the same indifference curve here, the better point would be C. So C is highest for Karen and also highest for James, right? So C will be efficient. Okay, so anything in the shaded area is considered mutually beneficial. It's just that we want to find which point is most efficient in that scenario. Now, it fulfills the efficiency requirement or condition, but D also fulfills efficiency requirement. Don't you think so? Yeah, because it is a tangent, but the only special thing about D is that it is the highest indifference curve for James. Remember, this is the higher the indifference curve in the indifference map here. This is for James. So in other words, you reach the tangency requirement, but you are doing this at the highest possible indifference curve for James and lowest indifference curve for Karen. So it is efficient, but if you look at D, yes, efficient, but will be in favor of James. Okay, so maybe James have got a stronger negotiation power. Maybe James is less desperate than Karen. Karen is more desperate, so she sacrifice more. So this is or the other way around. But there is an efficient, but could be the final efficient point can also depend on other factors, probably preferences or the negotiation power. So anyway, whatever point you if you take the equilibrium, all these tangency points, C, E, F, C, D, and all that just now, and you connect them, you could have what we call a contract curve. So every point on the contract curve is efficient because one person cannot be meter off without making the other person worse off. Okay. Now let's bring in price line or budget line here. The price line, let's say price of food is 1, price of clothes is 1, okay, or 10 and 10, regardless. But the slope of PL over PF over PC is equals to -1, yeah, because it's negatively sloped, and that -1 happens to be this P prime. So P prime, that is the budget line or the price line, yeah, price ratio line. And since it is also the same, it is also tangent to the two indifference curve, Karen's and James at C, tangent at C. Okay, so we say this is an equilibrium. Yeah, the price of the two goods determine the terms of exchange, so that particular exchange will provide an equilibrium. So we call this competitive equilibrium that is efficient. It is competitive because it's broad market and it's efficient. Now let's say the price is not, the ratio is not 1:1. Okay, let's say F and C, the ratio is not 1. Let's say it's 1:3, for instance. So the slope will be different, right? The slope will be like this, and the tangent may not be, you won't come to the competitive equilibrium. So the disequilibrium in this in these two markets, for these two people, you will have excess demand happening, or to the other side you will have excess supply, right? Depending on how you value the price. If price of clothing is higher, that means there will be excess supply of clothing, and then if there is price of food is lower, there will be excess demand. So either way, price will again adjust, yeah, so that you will get the disequilibrium is just temporary. Feedback effect will happen, and you will get a new general equilibrium between the two. Okay. So what we call economic efficiency, the competitive equilibrium just now from the consumer perspective, the indifference curve must be tangent. All marginal rates of substitution between consumers are equal, and then each of the indifference curve is tangent to the price line, so the MRS is also equal to the ratio of prices in the two goods. Okay, so you have James, this one, you have marginal rate substitution with the customer are equal, these two are equal, and the second condition is that the MRS are also equal to the price ratio. Okay, and that's the condition for a competitive equilibrium. So this is the number 1 rule, and then the number 2 rule is that both of them are equal to the price ratio. Okay, we stop here. Thank you very much.